Good afternoon, students. Am I audible? Yes, am I audible, students?
Yes, ma'am.
Okay. We will just wait for 5 minutes. Okay, so almost 64 students are there now. So let us start with the lecture. Okay, whether the slides are visible?
Yes, ma'am.
Okay. So in the previous lecture, we have seen the Z-buffer algorithm. And in Z-buffer algorithm, we have seen according to the depth of the objects from the viewer, the distance between the object and the viewer along Z-axis, that is considered as depth. And the shortest distance is present at the top. So that is considered as the front object, which has the minimum Z parameter with it. And accordingly, we are sorting the Z values in the Z buffer and its corresponding intensities in the another buffer. And we are preserving those two buffers at the same time, Z buffer as well as intensity buffer, right? So that was the Z buffer algorithm. Then this new algorithm we have started with, that is known as Penter's algorithm, or it is also called as depth sort algorithm. So in this algorithm, the sorting of surfaces is done based upon their Z values, and it is considering the greatest value first. So it is exactly opposite as that of your Z buffer algorithm. It is going to draw the farthest objects first, and then it will concentrate on the objects which are near with respect to the viewer. So we have seen the example of drawing the picture by a painter. So in that picture, he is drawing the hills and yes, is there any difficulty? And just check whose mic is on and make sure that your mic is off, all of you. Okay, so in the Penter's algorithm, why the name is given as Penter's algorithm? Because it is using the same concept as that of Painter while drawing the object. So this method uses both approaches of object space method and image space method, because the real object, it is going to consider the physical coordinate system, and while drawing it on the screen, it is going to consider the screen coordinate system. So it is taking the benefit of both the approaches that are object space method and image space method. Now here, whenever any painter draw any image, then it first draw the objects which are farthest. For example, in a nature scene, the painter draws first the mountains and then the objects which are near to him. So in the same way, here also in Penter's algorithm, the sorting of the surfaces is done, which has the largest Z value that is considered first. So sorting of all surfaces is done, and the surfaces surfaces which are closer, they are replaced by the surfaces which are at far. So the closer surfaces are replaced by the far surfaces. So first we are going to consider the far surfaces, and then we are going to consider the surfaces which are closer. So that is the working of Penter's algorithm. Then in that case, we are going to first see whether the surfaces are overlapping. So for that, first of all, the overlapping is checked with respect to the Z parameter. So we have seen this particular method in which the Z parameters are compared. Okay. So first we are going to check the overlapping, and if Z overlapping is not there, then it will check for the, it will decide the order. So we have seen the diagram in which now this axis is acting as your Z axis, this axis is acting as your X axis, and here the 90-degree axis is considered as Y axis. So here I am drawing one surface, So the surface is S dash and the other surface is S. So we have considered these two surfaces, S and S dash. Now this S surface is having the Z coordinates, Z maximum and Z minimum. Similarly, S dash is also having Z maximum and Z minimum values. And as they are not overlapping, they have separate Z parameters for themselves. So they are considered in the same order. The Z, whatever the Z is maximum, it is going to consider first. So S surface is taken first, rendered or processed first, and then you are going to have S dash surface. Okay, so that was our test 0. So we have seen there are total 4 tests, right? So total 5 rather. So if I'm considering test 0, then along with test 0, you are having total 4 more tests to carry out. Okay, so this thing we have already done. If surfaces are non-overlapping along z-axis, then it is considering the maximum z value surface first. So it is going to consider S first, followed by S dash. So this is the order which is fixed one. Okay, then if this condition fails, if test 0 fails, that means the surfaces are overlapping now. हे दोन surfaces आहेत जे overlap करत नाहीयेत. They are separate surfaces with respect to z values. पण आता जर माझ्याकडे surfaces असतील, if I am having the surfaces which are overlapping along z. For example, this is your S dash and this is your S surface. Or instead of that, I will draw the S here. Okay. So what is happening now? This is your S and this is your S dash. So if you consider now the Z parameters, so this is your Z maximum for the S and this is Z minimum. This is Z minimum. And here you are having the Z maximum for S dash and Z minimum for S dash. So in this example, the Z parameter of S and S dash, they are overlapping for this much portion. You can observe this portion is common for S as well as S dash. So here we cannot predict which surface is at the back and which surface is at the front. So we cannot predict here. And for that, the test number 1 is carried out. So what test number 1 tells us? I told you to take the screenshot of the screen, right? I told you to have the screenshot of the screen. So here you can view in that. So the test 1 suggests that you have to take the bounding box rectangle. So bounding rectangle of the surfaces and project it on the x-axis. So once you have the bounding rectangle for the surface and when you project it on the x-axis, then if the surfaces are not overlapping on x-axis, then you don't have to reorder the surfaces. Okay, so we have seen that when we are drawing the bounding box or the bounding rectangle for the surfaces. So this is the smallest rectangle which can occupy the whole surface. The smallest rectangle which can occupy the whole surface is the bounding rectangle. Now project that rectangle on x-axis. So I am projecting this rectangle on the x-axis. Now tell me whether the surface S dash and S, they are overlapping along x. Yes, whether S dash and S, they are overlapping. Yes, reply students.
No.
Right. So here S and S dash are not overlapping along x-axis, and that's why there is no need to change the order. We can have the same order, like S is rendered first, that is S is processed first, and then S dash is processed. So to check this order, we are going to take this test number 1. Okay, so that is about test number 1 that we have already studied. Now, if test number 1 also fails, what is the meaning of this? Test number 1 also fails. So I will draw the diagram over here, where this is your S dash. Sorry, this is your S, and here is my S dash. Okay, here is my S dash. Now check whether they are overlapping along Z axis. Can you tell whether they are overlapping along Z axis?
Yes.
Yes. Whether they are overlapping along X axis?
Yes.
Yes. So these are the two surfaces S and S dash which are overlapping along Z. You can see here, if I extend these, then I will have this particular thing where S dash and S, they are in overlapping. So we are having this particular portion where they are overlapping along Z axis. And here, if I consider the vertical lines, that is the bounding box, bounding rectangle, then also you can observe for this particular portion, your S and S dash are overlapping. So here the test 1 fails. Test 1 also fails. What test 1 tells you? They should not overlap along x-axis. Then you can keep the order same. But when this test 1 fails, that means along x-axis also they are overlapping. Along x-axis also they are overlapping. Then you have to check the the surface which is at the front and the surface which is at the back. So the second number test, if you have screenshot in your mobile, then you can check. The second number test tells us that the overlapping surface is at the completely at the back side, and the third number step tells us whether the overlapping surface is in front of the S dash. So it is checking among S and S dash the surfaces which are overlapping to each other, which are in front and which is at the back. So second number step is suggesting the surface either S or S dash is at the back, and similarly whether S or S dash is at the front. Okay, so second number test and third number step is one and the same. Rather, it is checking whether which surface is at the back and which surface is at the front. Now, how to check this? How to check which surface is lying at the back? Okay, so for that we can have the expression of the surfaces. So we have seen we are going to conduct the, for these two steps, we are going to conduct the inside outside test. So already we have carried out this inside outside test. Where we have carried out this? Where we have carried this inside outside test? In the same chapter. Yes. Yes, student. Step test number 0 and test number. Yes, backface detection, right? Very good. So, is there any difficulty in test number 0 and test number 1? Yes. Anyone has not understood this test number 0 and test number 1? Is there anyone who has not understood this? Okay, so shall I conclude that all of you have understood test number 0 and 1? Okay, so when 1 fails, that means the case is like this. It has overlap along x-axis. It has overlap along z-axis as well, z and x. In both the direction, the surfaces are overlapping. Then if the surfaces are overlapping, yes, just check whose mic is on. Okay, so the case is like this, in which the surfaces are overlapping on x as well as z axis. So in that case, you have to check which surface is a background surface and which surface is present at the front. And for that purpose, we are carrying out second number and third number test. Now what I will do is, I will consider any point on S. I will consider any point on S. So in the second number step, I will consider a point P, which is lying on S surface, which is having the coordinates x, y, z. Okay. In the second number step, I will take a point which is lying on S. So a point, consider this point P, which is lying on surface S. And then I will put the coordinates of P, that is x, y, z, in the formula of S dash. Okay, what I am doing, I am taking the point on S, I am taking the point on S and putting those coordinates in S dash. Now S dash is having a formula ax plus by plus cz, ax plus by plus cz plus d. Okay, this is the formula for S dash. Now if this value is less than 0, if this value is less than 0, then we have seen that the point is lying inside. The point is lying inside. That means if this value is less than 0, means it is having the z value which is less than the S dash, because S dash is having the formula. What S dash is having the formula? In the S dash, when I will use this formula ax plus by plus cz plus d, it is equal to 0. This formula is equal to 0, right? S dash is having this particular formula which is equal to 0. But when I put p value with x, y, z less than 0, जेव्हा एक्स वाय झेड ची व्हॅल्यू पुट केल्यानंतर ह्याची व्हॅल्यू लेस दॅन 0 येत असेल, त्याचा अर्थ काय येईल की इथे झेड ची व्हॅल्यू इज लेस. झेड ची व्हॅल्यू इज लेस, and that's why the what we are doing, we are sorting the surfaces according to the greater value of z, according to the larger value of z. मग जर ही व्हॅल्यू लेस दॅन 0 आली, that means this xyz point is at the back. Inside, that means on the back side of the S dash, and that's why you have to consider the same order, that S is at the front and S dash is at the back. Okay, so you are going to consider a point on S and keep the coordinates of that point in S dash. If you are going to get the less than value, then that means the point is inside, that is back side, and you have to keep the order as it is. Similarly, in step number 3, exactly opposite you have to do. In step number 3, consider a point which is now on S dash. The point is on S dash and keep this value in S. Exactly reverse thing we are going to do in step number 3. So we are going to take a point which is on S dash and you have to put the value in the S. So if it is in the front, what is the meaning of front? If S is on the front of S dash, that means this value should be greater than 0. This value should be greater than 0. So when I am putting the point P on S formula, then I will get the ax plus by plus cz plus d value greater than 0. So if it is true, then S is in the front of S dash. So it is considered in the same manner in the both second and third number test. We are going to apply the same method, that we are considering a point and keeping that point's coordinate on other surface equation. And if I am getting the less than 0 value, then it means it is on the back side. If we are getting the greater than 0 value, then it is considered as in the front. Accordingly, we are going to test for the second number and third number step. And in that case, if these two fails, what is the meaning of that? If second number test also fails and third number test also fails, means S and S dash are the two surfaces which are neither completely backside of each other and nor completely front of each other. There are two surfaces which are neither completely at the back or nor completely at the front. That means some portion of S dash is on the back side while the remaining portion is at the front side, and vice versa. So S is having the intersecting kind of property. Some portion of S is on the front and some is at the back. Similarly for S dash. So these are the two steps. If both of them will fail, then you have to consider the fourth number step, that is called as projection. So you have taken that step in your snapshot. So the projection you have to consider. So you have to take the projection of the surfaces, and that projection, if gives you the idea that the in the projection you are going to get that total surface is intersecting. For example, now I am going to draw it in the two-dimensional kind of thing. So here, this is your surface number 1 and the surface number 2. So consider this is the case. Or I can say S and S dash. This is your S and this is your S dash. right? So S and S dash are the two surfaces. So if you observe the viewer side, that S and S dash, they are overlapping along x-axis, along z-axis as well as along x-axis, and they are neither at the back of each other nor at the front, because if you are viewing from this side, then you are able to observe S dash as well and S as well. दोन्ही surfaces तुम्हाला visible आहेत, plus they are overlapping of each other along Z and X direction. जर अशी केस असेल तर काय करावं लागेल, मग तुम्हाला प्रोजेक्शन घ्यावं लागेल along y axis. So you are going to take the projection of both the surfaces along y. Okay. आणि मग along y जेव्हा त्याचं प्रोजेक्शन घेईल तेव्हा तुमच्या लक्षात येईल की which surface is at the front. So this overlapping portion कुठल्या कलरचा असेल. जर S फ्रंटला असेल, S जर फ्रंटला असेल तर काय होईल, हा पोर्शन समजा S चा कलर रेड कलर आहे. S is of red color and S dash is of blue color, for example. Then what will happen? This portion, we are not able to decide the overlapping portion is of which color. The overlapping portion is of which color, because it is the surface is overlapping along Z, the surface is overlapping along X, and the surface is neither totally backside nor totally front side of each other. कळतंय आता तुम्हाला हे? With this diagram we can see that the surface if totally backside असेल तरी आपण त्याची order of the operation consider करू शकतो, किंवा totally front असेल तरी आपण त्याची order of operation decide करू शकतो. But here the conflict is there because they are overlapping, and that's why the fourth step is considered. We are going to take the projection along y. So we are going to take the projection of these two surfaces along y, and then we will check whether S dash is having the greater value of y or S is having the greater value of y. So this is towards negative y axis. So consider now your S is on the back side. Consider that your S is having the negative y value, or we can say that the value of y on S is smaller than that of the value of S dash y. What is the meaning of this? S dash ची y ची value जास्त आहे, so this is your positive side, and S dash is towards positive side, म्हणजे towards front. Towards front. So if this is the case, sy ची value जर लहान असेल S dash of y, then you don't have to alter the order, because पाठीमागचाच पोर्शन आपण पहिल्यांदा ड्रॉ करतोय पेंटर्स अल्गोरिदम प्रमाणे. सो sy ची व्हॅल्यू पाठीमागची म्हणजे टुवर्ड्स निगेटिव्ह y ऍक्सिस आहे. सो वी आर गोइंग टू हॅव द सेम सिक्वेन्स S आणि नंतर S डॅश, कारण S बॅकग्राऊंड साइडला आहे आणि S डॅश फ्रंटला आहे. सो वी हॅव टू कीप द ऑर्डर सेम. बट इफ रिव्हर्स इज द केस की S डॅश ची y ची व्हॅल्यू इज लेस दॅन S ऑफ y असेल, म्हणजे हा आता बॅकग्राऊंडला असेल, S डॅश इज ऑन द बॅक साइड, तर त्या केसमध्ये तुम्हाला काय करावं लागेल, रिऑर्डर करावं लागेल. सो यू आर गोइंग टू रिऑर्डर द सर्फेसेस. मग त्या केसमध्ये तुम्हाला काय करावं लागेल, you have to reorder. First you have to consider S dash and then you have to consider S. Okay, all of you are getting this now? Yes, students. Yes, students. Tell me yes or no. जर कळलं असेल तर येस म्हणा, नसेल कळलं तर काय रिपीट करायचं ते सांगा.
मॅम लास्ट पॉइंट रिपीट करा.
This one, fourth one.
हा येस मॅम.
Okay. So see here, सेकंड आणि थर्ड नंबर स्टेप मध्ये काय कळतं आपल्याला की कुठला बॅक साइडला आहे आणि कुठला फ्रंट साइडला आहे. ओके, म्हणजे आपण कन्क्लुजनला पोहोचतो की एकाच लाईनवर जर मी ऑब्जेक्ट प्लॉट केले असतील तर आयदर इथं एस असेल आणि टोटली एस डॅश हा टोटली त्याच्या पाठीमागे असेल, राईट, किंवा वाईस वर्सा, एस पाठीमागे असेल आणि एस डॅश पुढे असेल. तर त्या केसमध्ये काय होईल, तर त्या केसमध्ये असेल ते की विथ रिस्पेक्ट टू वाय ऍक्सिस दे आर नॉट ओव्हरलॅपिंग. ते ओव्हरलॅप नाही करत आहेत एकमेकांना, ते लांब आहेत. सो इव्हन दो दे आर ओव्हरलॅपिंग अलॉंग एक्स अँड अलॉंग झेड, आतापर्यंत काय बघितलं होतं, एक्स आणि झेड बरोबर ओव्हरलॅप होत होते, म्हणून आपण त्याचं चेक केलं की कोण कोणाच्या बॅक साइडला आणि कोण कोणाच्या फ्रंट साइडला आहे. तर त्या केसमध्ये जर फ्रंट आणि बॅक आपण इन आउट टेस्टनी कॅल्क्युलेट केलेला आहे. बॅक साइड आणि फ्रंट साइड वी आर कॅल्क्युलेटिंग विथ दिस इन आउट टेस्ट. जर बॅक पण नसेल कम्प्लिटली आणि फ्रंट पण नसेल कम्प्लिटली, म्हणजे दोन प्लेन पेपर आहेत, ते एकमेकांवर रिसाइड केले असतील आणि वरच्या पेपरचा पण थोडा भाग विजिबल आहे आणि खालच्या पेपरचा पण थोडा भाग विजिबल आहे. या केसमध्ये बघा, तुम्हाला एस चा पण थोडासा सरफेस विजिबल आहे एवढा आणि एस डॅश चा पण विजिबल आहे, म्हणजे टोटली दोघं एकमेकांच्या पाठीमागे किंवा पुढे. आय कॅन नॉट जज त्या केसमध्ये कोण पुढे आणि कोण पाठीमागे. ठीक आहे, कारण सेकंड नंबर स्टेप आणि थर्ड नंबर स्टेप काय सांगते, सेकंड नंबर स्टेप सांगते की एस इज टोटली ऑन द बॅक साइड ऑफ एस डॅश किंवा एस इज टोटली ऑन द फ्रंट साइड ऑफ एस डॅश. हे दोन टेस्ट सॅटिस्फाय करतं. दॅट मीन्स एकतर एस डॅश विजिबल असेल टोटली किंवा एस विजिबल असेल टोटली. ओके, डिफरन्स कळतोय सेकंड, थर्ड आणि फोर्थ नंबर स्टेप मधला. येस
मॅम.
राईट. सो सेकंड अँड थर्ड काय सांगतात की एकच सरफेस कुठला तरी विजिबल आहे, मग कुठला आहे तो फ्रंटचा आणि बॅकचा हे मी कॅल्क्युलेट करतेय. ओके, पण आता दोन्ही सरफेस मधला थोडा थोडा पोर्शन विजिबल आहे. फॉर एक्झाम्पल, जर ऑब्जेक्ट असं असेल तुमचं, आपण एक काढलं होतं आधी, हे एक आहे आणि त्याच्या पाठीमागे ओके असं ऑब्जेक्ट आहे समजा. तर काय होतंय आता, मी हे जर व्ह्युअरची डायरेक्शन असेल तर मला हे पोर्शन पण विजिबल आहेत आणि हा पण विजिबल आहे, बरोबर. जर ही व्ह्युअरची डायरेक्शन असेल तर मला हे ओव्हरलॅपिंग ऑब्जेक्ट आहेत म्हणून हे पण विजिबल असेल, हा पण विजिबल असेल आणि हा छोटा पोर्शन उभी जी पट्टी आहे ती पण मला विजिबल असेल. पण आता मी आता जर हे अल्गोरिदम वापरते तर मग मी कम्प्लिटली तो पुढे का पाठीमागे हे जज नाही करू शकत आहे. दोन सरफेसेस जे कम्प्लिटली पुढे आहे का कम्प्लिटली बॅक साइडला आहे, आय कॅन नॉट जज. किंवा या केसमध्ये सुद्धा दोन ऑब्जेक्ट असतील असे तुमचे 3 डायमेन्शन मधले, की आय कॅन नॉट जज वेदर एस अँड एस डॅश कुठला सरफेस फ्रंटला आहे आणि कुठला बॅकला आहे, कारण त्याचा स्मॉल पोर्शन ओव्हरलॅपिंग आहे. उरलेला पोर्शन मला एसचा पण दिसतोय आणि उरलेला पोर्शन मला एस डॅशचा सुद्धा दिसतोय. सो इन दिस केस आय कॅन नॉट रेकग्नाइज की पाठीमागची म्हणजे बॅकग्राऊंडचा सरफेस कुठला आहे आणि फ्रंट कुठला आहे, मग दोन्हीपैकी प्रोसेस कुठला आधी करायचं, कारण पेंटरचा अल्गोरिदम काय म्हणतं की जो बॅक साइडचा पोर्शन आहे तो आधी प्रोसेस करायचा आहे तुम्हाला. ओके, मग आता ह्याच्यामध्ये मी डिसाईड नाही करू शकत आहे की एस डॅश इज ॲट द बॅक और एस इज ॲट द बॅक. म्हणून मी काय करतेय, प्रोजेक्शन घेतेय त्याचं वाय वरती. त्याचं प्रोजेक्शन वाय वरती म्हणजे काय, थोडक्यात त्याची वाय कोऑर्डिनेट चेक करतेय. सो वाय कोऑर्डिनेट पॉझिटिव्ह म्हणजे टुवर्ड्स व्ह्युअर आणि वाय कोऑर्डिनेट निगेटिव्ह म्हणजे अवे फ्रॉम व्ह्युअर. जेव्हा वाय कोऑर्डिनेट 0 मायनसच्या साईडला जाईल म्हणजे ते पाठीमागच्या बाजूला जातं आणि वाय कोऑर्डिनेट इज पॉझिटिव्ह म्हणजे विच इज कमिंग टुवर्ड्स व्ह्युअर. ओके, मग या केसमध्ये जर एस चे सरफेसचा वाय कोऑर्डिनेट, एसचा वाय इथे कुठेतरी प्लॉट झाला म्हणते मी की दॅट इज माय वाय कोऑर्डिनेट ऑफ एस. एस सरफेस इथे वाय वरती तो लाय होतोय. सो एस ची वाय व्हॅल्यू जर लेस दॅन एस डॅश ची वाय व्हॅल्यू असेल, एस डॅश ची वाय कुठे असेल, समजा इथे लाय करते, एस डॅशचं वाय पॅरामीटर इज हिअर समवेअर. मग ही जर एस ची वाय व्हॅल्यू आणि एस डॅश ची वाय व्हॅल्यू ह्याच्यातलं रिलेशन बघा. जर एसचा वाय व्हॅल्यू इज स्मॉलर दॅन एस डॅशचं वाय असेल. स्मॉलर म्हणजे काय, केव्हा व्हॅल्यू स्मॉलर होईल, जेव्हा ते पाठीमागच्या बाजूला असेल तेव्हा. वाय ची व्हॅल्यू कमी कधी असेल, जेव्हा ते मागच्या बाजूला असेल तेव्हा वाय ची व्हॅल्यू कमी असेल. सो जर एस वाय ही लहान असेल एस डॅश वाय पेक्षा तर तुम्ही ऑर्डर चेंज करायची काहीच गरज नाहीये, कारण ऑलरेडी एस वाय हा पाठीमागेच आहे. एस वाय ची वाय व्हॅल्यू कमी आहे म्हणजे टुवर्ड्स निगेटिव्ह आहे. समजा एस वाय ची व्हॅल्यू असेल तुमची 10, एस वाय ची व्हॅल्यू इज 10 आणि एस डॅश वाय ची व्हॅल्यू आहे 15. याचा अर्थ काय आहे, तर एस वाय ऑलरेडी हॅव्हिंग मायनस व्हॅल्यू, त्याच्या पुढच्या साईडला तुमचा एस डॅश वाय आहे. ओके, अलॉंग या ऍक्सिस वरती इथं बघितलं तर इथे तुमचा एस वाय आहे आणि इथं एस डॅश वाय आहे. हे 10 आहे आणि हे 15 आहे, बरोबर. सो 10 आहे पाठीमागे, मग पाठीमागे म्हणजे बॅकग्राऊंडच पहिले प्रिंट होतंय आणि आपल्या पेंटर्स अल्गोरिदम प्रमाणे बॅकग्राऊंडच व्हायला पाहिजे. सो व्हॉट एव्हर ऑर्डर आपण आधी जी डिसाईड केली होती, पहिल्यांदा एस आणि नंतर एस डॅश, ही चेंज करायची गरज नाहीये. बिकॉज एस वाय इज हॅव्हिंग लेस व्हॅल्यू दॅन दॅट ऑफ एस डॅश वाय, दॅट मीन्स इट इज लाईंग ऑन द बॅक इटसेल्फ, पाठीमागेच आहे हा. सो वी आर गोइंग टू ड्रॉ दिस और वी आर गोइंग टू रेंडर दिस सरफेस फर्स्ट. पण आता जर उलट असेल, एस डॅश ची व्हॅल्यू 10 असेल आणि एस वाय मात्र 15 असेल, तर काय होईल, इथे तुमचा एस डॅश वाय आहे म्हणजे तो पाठीमाग आहे आणि एस वाय इथे आहे जिथे 15 व्हॅल्यू आहे. सो एस वाय ची व्हॅल्यू 10 आहे, तो मागे आहे, आणि सॉरी एस डॅश वाय ची व्हॅल्यू 10 आहे, तो पाठीमागे, आणि एस वाय ची व्हॅल्यू 15 आहे, तो पुढे. मग पुढचा ऑब्जेक्ट आपण आधी ड्रॉ करायचा आहे का, नाही. आपल्या पेंटर्स अल्गोरिदम प्रमाणे मागचा ऑब्जेक्ट आधी ड्रॉ करायचा आहे. मग मागचा ऑब्जेक्ट आपला आहे एस डॅश वाय, म्हणून तुम्हाला ऑर्डर चेंज करावी लागेल, जी आपण पहिल्यांदा अज्युम करत होतो ऑर्डर, की आधी मागचा ऑब्जेक्ट म्हणजे एस ड्रॉ कर. पण आता आपल्याला 5व्या या प्रोजेक्शनच्या स्टेप मधून कळालंय की एस डॅश वाय हा पाठीमागे. सो वी विल चेंज द ऑर्डर. आधी एस नाहीये, आधी एस डॅश आहे. सो रिऑर्डरिंग विल टेक प्लेस हियर. आता कळलंय?
Yes, ma'am.
Okay. Boys side, all of you are clear with this?
Yes, ma'am.
Okay. If you have any doubt, ask it right now only, because this algorithm is having these 3 steps quite confusing. But okay. So by using these 4 tests, we are able to judge which surface we have to draw first or process first. Okay, so Penter's algorithm uses background surfaces first and then the front surfaces which are closer to the viewer. Okay. So let us read these steps first again. So it sorts all the surfaces according to the distance from the viewpoint. Render the surfaces to the image buffer one at a time, and starting from the farthest surface. So लांबचा surface आधी process करायला चालू होतो. Render म्हणजे process. Surfaces close to the viewpoint will replace those which are far away. So we are going to replace the closer by the farther surfaces. After all surfaces have been processed, the image buffer stores the final image. So once this surface processing is done, the image buffer will contain the final image. And the basic idea of this method is simple. When there are only few objects in the scene, this method can be very fast. However, as the number of objects increases, the sorting process can become very complex and time consuming. So this is very important, same as that of Z buffer algorithm. जेव्हा less number of objects असतील, then we can use this sorting method efficiently. But at a time, if we want to, आता आपण दोनच surfaces बघत होतो, I mean sort करत होतो, पण असे जर total 10 to 12 objects will be there, and those 10 to 12 surfaces, if you want to process, then that sorting will become obviously complex and time consuming. Okay. So we have seen this example that how the overlapping is checked, and accordingly how inside, outside, behind, and in front tests are carried out. So overlapping surface with outside test and all, and then we are checking the thing with projections. So that are nothing but greatest depth and all that we are checking. And this depth sorting method uses both image and object space operations. Okay, so that is about Penter's algorithm. Okay, so these are the 5 steps. And the last step is the projections we have to carry out. Okay, so that is about the Penter's algorithm. And now the last algorithm is remaining, that is area subdivision, or it is also called as Warnock algorithm. Okay. So the next algorithm is area subdivision. This algorithm is very simple and it is applicable for many complex objects, right? Because the drawback of Z buffer and Penter algorithm was that they two algorithms were not applicable for the complex objects which are overlapping, or large number of objects which are overlapping each other. So that disadvantage is overcome in this area subdivision, or it is also called as Warnock algorithm. Because this algorithm was developed by John Warnock, who has developed this method of area subdivision. This method uses the image space method or image space approach. That is the screen coordinate system is considered here in this example or in the algorithm. And it uses the divide and conquer method. What is the meaning of divide and conquer? So the total screen is divided into number of small areas. The total screen is divided into number of small areas, and then that areas, it is considering four conditions, whether the area and polygon is having certain a relationship between them. So accordingly, it is considered. So let us see how this method uses the visible line and visible surfaces detection. So let us start with the algorithm. So the name is area subdivision algorithm, or it is also called as Warnock. This was invented by John Warnock and also called as Warnock algorithm. It is based on divide and conquer method. It uses the fundamental of area coherence, right? So this is very important point, area coherence. So objective type question, it many times it comes in the question paper that the area subdivision algorithm is based on this dash dash technique. So the options are like scanline coherence, pixel coherence, area coherence. So the answer is area coherence. So what is the meaning of that? It is nothing but it is going to consider the similar properties of the area. Like consider this rectangle. If I am going to consider the rectangle, what is the common property inside of inside pixels? So all these inside pixels, they are of blue color. So I'm pointing them out with red dots, but basically those all pixels which are in this box, they are of blue color, that is background color. So all pixels in a specified area having the same property is called as area coherence. So in this area, all pixels provide you the same color. If I consider this box, then you will find half of the box is giving you white color pixels and half of the box is giving you blue color pixels. So here okay. So here so the half of the box is of white color and half of the box is of blue color. So here the area coherence is applicable only for the half portion of the box. But here if you consider the whole box is of blue color, and it is giving you the property of area coherence. In this area, all pixels are giving you the same property or same intensity rather. Okay. So it is used to resolve the visibility of algorithm, right? So it classifies the polygon in two cases, that is trivial and non-trivial. So we will see what is trivial and non-trivial. The trivial cases are easily handled. Non-trivial cases are divided into 4 equal sub-windows. So this is very important. Trivial cases. Trivial cases means there is no overlapping of the object, right? जर एक एरिया मी घेतलं तर त्या एरियामध्ये एकच ऑब्जेक्ट प्रेझेंट असेल, ओव्हरलॅपिंग कंडिशन्स नसतील. फॉर एक्झाम्पल okay, this is your area in which I am having one object like this and the second object like this. So in this area, two objects are present and they are overlapping each other. So what I can do is I'm going to divide the area in 4 sub windows because this is the example of non-trivial case. जे easily handle नाही करू शकत अशी case आहे. So it is considered as non-trivial case. Instead of that, जर माझ्याकडे एक rectangle असला असता or the area असला in this area, only there is one object present. So there is no need to divide this area into 4 sub windows. So I am going to consider only this area and the object because here no overlapping is there, single object is there. These cases are called as trivial cases where they are easy to handle. But non-trivial cases म्हणजे area and it has multiple overlaps. So to process further, what we have to do is we have to use the divide method. We have to divide that window into 4 sub windows. So I'm going to divide it into 4 sub windows. Okay. Now what will happen? If I consider this window number 1 and window number 2, now they are trivial or non-trivial? Yes, students. आपण एक होल विंडो कन्सिडर केली होती ज्याच्यामध्ये ऑब्जेक्ट्स होते ते ओव्हरलॅप होत होते. सो ओव्हरलॅपिंग विंडो असेल तर त्याला म्हणतात नॉन ट्रिव्हियल विंडो. मग जर नॉन ट्रिव्हियल केसेस असेल तर फर्दर काय करायचंय, वी हॅव टू डिव्हाइड इट इंटू 4 इक्वल सब विंडोज. मग मी डिव्हाइड केलं त्या विंडोला इक्वल सब विंडोज मध्ये. आता मला काय मिळालंय, ही एक सब विंडो आहे 1 नंबर 2 नंबर 3 नंबर अँड 4 नंबर. दीज आर टोटल 4 सब विंडोज. मग आता 1 नंबर आणि 2 नंबर हे ट्रिव्हियलचं एक्झाम्पल आहे का नॉन ट्रिव्हियलचं आहे आता?
Non-trivial.
नो नो, नाव इट इज ट्रिव्हियल. फक्त तुम्ही आता एक नंबर विंडो बघा. एक नंबर विंडो मध्ये कुठलं ओव्हरलॅपिंग आहे का? नाहीये. एवढाच ऑब्जेक्ट आहे आणि विच इज ओनली व्हाईट ऑब्जेक्ट. ब्लॅकचं ओव्हरलॅपिंग आहे का त्याच्यामध्ये? नाहीये. तसंच 2 नंबर मध्ये सुद्धा एकच ऑब्जेक्ट प्रेझेंट आहे व्हाईट कलरचा ज्याच्यामध्ये ओव्हरलॅपिंग नाहीये. सो जेव्हा एक होल विंडो कन्सिडर केली होती तेव्हा ओव्हरलॅपिंग होतं म्हणून मी त्याला डिव्हाइड केलं आणि डिव्हाइड केल्यानंतर ज्या स्मॉल सब विंडो मिळाल्यात आता मला त्याच्यामध्ये ओव्हरलॅपिंग नाही येते 1 नंबर आणि 2 नंबर मध्ये. सो आय कॅन यूज देम ॲज ट्रिव्हियल केसेस. आणि आता 3 आणि 4 मध्ये बघा, 3 आणि 4 मध्ये स्टील देअर इज ओव्हरलॅपिंग. 3 मध्ये पण पोर्शन ऑफ ब्लॅक आहे आणि व्हाईट आहे. 4 मध्ये पण पोर्शन ऑफ ब्लॅक आहे आणि व्हाईट आहे. सो अगेन आय एम गोइंग टू सब डिव्हाइड देम. परत माझं काय काम आहे तर त्याला परत एकदा सब डिव्हाइड करायचं 3 ला पण. मग आता जर 3 मधले हे 2 पोर्शन बघितले तर ते काय होतील तुमचे? ट्रिव्हियल होऊन जातील ज्याच्यामध्ये फक्त एक ब्लॅकच कलर आहे आता माझ्याकडे. गेटिंग इट? सो इन दॅट वे the whole window is recursively subdivided into 4 sub windows and we are reaching to a trivial case at the end. म्हणजे नॉन ट्रिव्हियलला डिव्हाइड करत 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 मला कुठपर्यंत पोहोचायचंय? ट्रिव्हियल मध्ये, जेव्हा त्याच्यामध्ये एकाच प्रकारचा ऑब्जेक्ट असेल, ओव्हरलॅपिंग टोटली रिमूव्ह झाला असेल असा केस. ओके. So we are going to recursively divide the window into 4 sub windows. Okay. So that is called as area subdivision. So now what? Actually the time is up. You have next lecture. Do you have next lecture? The link is given. Yes, tell me whose next lecture is which is your next lecture? Maths. Okay, still
Yes.
the link. Yeah, still the link is not there. Till that time we can continue. Okay. So in this Warnock algorithm, what the Warnock suggests, you have to divide the screen and into 4 सब विंडोज. आत्ताच आपण बघितलं की आपण स्क्रीनला 4 सब विंडोज मध्ये डिव्हाइड करत जायचंय जोपर्यंत तुम्हाला फायनल ट्रिव्हियल केस मिळत नाही तोपर्यंत. मग ट्रिव्हियल केस मिळाल्यानंतर तिथे 4 कॅटेगरीज असू शकतील. ट्रिव्हियल केस मिळाल्यानंतर त्याचे 4 कॅटेगरीज असू शकतील. फॉर एक्झाम्पल, फर्स्ट कॅटेगरी इज इनसाइड सरफेस. सो इनसाइड सरफेस म्हणजे काय, तर नेक्स्ट पेज मध्ये बघा. सो इनसाइड सरफेस इज नथिंग बट ही तुमची विंडो आहे ग्रीन कलरची अँड द ऑब्जेक्ट इज टोटली इनसाइड. म्हणजे तुम्हाला पहिल्यांदा दिलेलं होतं ही विंडो आहे तुमची, ही स्क्रीन आहे. स्क्रीन मध्ये okay, this is your object. Okay, this is your object. मग मी काय करणार आहे पहिल्यांदा, or I can say, okay, I will take one more object with it. Okay, right. हे टोटल तुमचं स्क्रीन आहे. Okay, this is your screen and you are having 2 objects with you. I will change the color for your, okay, no, okay, they are non-overlapping. So in this window I am having 2 objects. So 2 objects म्हटल्यानंतर this is your non-trivial window. मग non-trivial म्हटल्यानंतर तुम्हाला काय करावं लागेल, you have to subdivide it. You have to subdivide it. So this screen will be divided into 4 parts now. Okay, right, the screen is divided into 4 parts. मग आता बघा ह्याच्यामध्ये, if I am going to consider about this object, if I am going to consider only about this object, what will happen, this whole object is present in this window, where I will call it as 1A, first subdivision A part, first subdivision B part, first subdivision C part, and first subdivision D part. Okay, so A B C D, A B C D. Okay, that means if I'm interested in this particular image, then this image is totally present within this 1B. So this particular condition is called as inside, or it is that we are going to call that image is totally inside the screen, totally inside the screen. Now, what is the relation between 1C and this image? One C and the image. The image has no part which is lying in 1C. Are you agree with this? This image is totally present in 1B and it has no part which is lying in 1C. This condition is called as disjoint. This condition is called as disjoint, or it is also called as outside. That means when the object is totally away from the subdivided window, then it is called as outside. Okay, so I am having the condition. Two conditions are there. First condition is inside. That means the given object is totally within the sub window, then it is called as inside. Again, with respect to 1C, the object is totally outside. Similarly, with respect to 1A and 1D also, this object is totally outside. Okay, so that is about totally inside and totally outside. These two cases we have considered. Now the third case is contained, or we can say partially inside. So now consider this second object. The second object is partially inside 1A, partially in 1B, partially in 1C, and partially in 1D. Okay, so we are calling it as a partially present, right? So intersecting, it is also called as intersecting because some portion of it is present in 1A, some portion in 1B, some portion in 1C, and some portion in 1D. So there are total 4 sub windows which intersect the object. So this condition is called as intersecting. And the fourth condition is called as contained. Contained. So what is happening in contained? So in this, the total window is inside the object. For example, if I am going to subdivide this window again here I am subdividing it. Okay. So now if you see this portion, the portion which I have ticked, if you see this portion, then I will say the whole window which is of black color, the whole window is present inside the object. आधी काय होतं, विंडोच्या मध्ये ऑब्जेक्ट होता which was inside, आणि आता कंटेंट म्हणजे काय होतंय, एक्झॅक्टली उलट की ऑब्जेक्टच्या मध्ये कंप्लीट विंडो बसून गेली. सो दिस इज युअर ऑब्जेक्ट and the whole window is inside your object, then it is called as contained. Okay, so these are the 4 cases. हे कळालंय सगळ्यांना? What is the meaning of inside, outside, intersecting, and contained? Yes. Yes, students.
Yes, ma'am.
Okay. So we will see this inside surface. It is surface which is completely inside the window. He case. The surface is inside the window. Second is outside surface. That means with respect to 1C, the surface is totally outside, or it is also called as disjoint. Third is overlapping surface. So overlapping surface is nothing but the polygon surface completely encloses the window. That means he case, last case आपण जी consider केली होती ती. So the window is totally inside the polygon. It is called as contained or overlapping surface. And the fourth case is overlapping surface, in which partially inside and partially outside. So such example is considered as overlapping. Okay, so how this algorithm works? So we are going to divide the screen into 4 parts every time, and we are going to if the image is 2D, if the image is 2D, 2-dimensional, then we are going to divide it into 4 parts. If the image is 3D, then we are going to divide that image into 8 parts. These 4 parts along XY and similar 4 parts at the back along Z axis. So we are going to have this 4 partitions with along XY as well as along Z. So I will show that diagram also to you. Yes. So if the 2-dimensional divisions are taken place, then it is called as quad structure, quad tree structure, because 4, quad means 4. So every time we are dividing the screen into 4 sub windows, so it is called as quad structure. But if the 3-dimensional object is there, for example, this object, if the 3-dimensional object is there, then we are going to divide it into 8 parts. So 0, 1, 2, 3, similarly 4, 5, 6, and 7 background side. So total 0 to 7, that is 8 parts are done, and that's why this tree is called as oct tree. Oct means 8. So if 2-dimensional object is there, then division is carried out in 4 parts. If 3-dimensional object is there, the division is carried out in 8 parts. And when I am going to draw it in a tree-like structure, then it is called as quad tree or oct tree. For example, here for this window, first the 0th first subdivision, that is called as root or the screen. So total screen is there, and that screen is divided into 4 parts here. The first part is called as 1A, then 1B, then first C subdivision, and 1D. Again, this 1D is divided into 4 parts, which is called as 2A, 2B, 2C, and 2D, for example. So 2A, 2B, 2C, and 2D. And again, this A, B, C, D, suppose C portion, 2C is again subdivided into 4 parts, which is called as 3A, 3B, 3C, and 3D. So what will happen at the end? At the end, you might get pixels only, because this screen, the window size will get reduced, and you will get ultimately the leaf nodes as pixels. Okay. So in that way, the total screen is divided until you get the pixels. Or if area is having the same property, like here, this tick portion, which is suppose 3A portion. So 3A portion is totally surrounded, or it is contained in the object. मग या ऑब्जेक्टचा समजा रेड कलर असेल तर ह्या टोटल विंडोला कुठला कलर मिळेल? रेड कलर मिळेल. So further subdivision is not required. I will assign the red color to this 3A window and I will concentrate on the remaining portion. म्हणजेच मी काय करतेय, 3A या एरियाला मी इंटेन्सिटी प्रोव्हाइड करतेय. 3A या एरियाला मी काय करतेय, रेड इंटेन्सिटी प्रोव्हाइड केली, आणि फर्दर सबडिव्हिजन्स मला नको आहेत, कारण द टोटल एरिया मी किती वेळा त्याला पुन्हा डिवाइड केल्यानंतर मिळणारा कलर कोणता असणार आहे, त्या एरियाचा रेडच असणार आहे. सो I am reaching to the area coherence property where all pixels of this area is of same intensity, red intensity. तसंच या पण बॉक्सचं तेच होईल. This box is also inside the object, so I am going to assign 3A, 3B, 3C आणि 3D येत. आता हे 3C ला सुद्धा मी रेड इंटेन्सिटी करून टाकणार आहे, आणि आय विल स्टॉप फर्दर सबडिवाइडिंग 3C. 3C आता मी डिवाइड नाही करणार. ओके. त्याच्यानंतर काय होईल, पण हा मात्र पोर्शन आहे 3B पण आणि 3D पण, ज्याच्यामध्ये अजूनही बॅकग्राऊंडचा पण थोडा कलर येतोय आणि पिक्चरचा रेड कलर पण येतोय. मग मला त्याला फर्दर सबडिव्हाइड करावं लागेल. मग आता सबडिव्हिजन नंतर काय मिळालं बघा. हे दोन आता टोटली कंटेंट झालेत. सो या दोन पोर्शनला म्हणजे 4A आणि 4B असेल समजा, तर त्याला मी रेड कलर देऊन टाकेन. 4C, आता हा 4C जो पोर्शन आहे जो टोटली आउटसाइड आला आता ऑब्जेक्टच्या. 4C हा पोर्शन आहे टोटली आउटसाइड. सो आय विल प्रोव्हाइड द बॅकग्राऊंड कलर टू इट. म्हणजे आता माझा 4A, 4B आणि 4C तिन्ही प्रोसेस झालेले आहेत. फक्त 4D मला परत सबडिवाइड करावं लागेल. Okay, so in that way you are going to use the area coherence property to provide the same intensity to the specified area, and you go on subdividing the remaining areas until you get the same property. कळाले आता सगळ्यांना हे अल्गोरिदम? Yes, girls? Yes, girls, all of you have understood?
Yes, ma'am.
Okay, boys side? Yes. Boys side, all of you are understanding? A35, Atharva. Roll number 35, A division. A35, you are there or shall I put absentee? A44, Om. A division 35, A division 44. I'm making you as absent. A45, Ganesh. So if you are not giving any answer, I am treating you as absent. Roll number 38, Pradeep. Roll number 41.
Yes, ma'am.
What is your roll number? 38.
38.
Okay. Have you understood?
Yes, ma'am.
Okay. Then roll number 41, Krishna. Roll number 47, Suraj.
Yes, ma'am.
Have you understood?
Yes, ma'am.
Okay. Roll number 49, Chetan. Roll number 50, Jeevan. .51, Ganesh.
Yes, ma'am. Hello, ma'am.
Yes, what is your roll number?
51.
51. Okay. Have you understood?
Yes, ma'am.
Okay. Roll number 52, Harsh. 53. Roll number 61, A division, Somnath.
Yes, madam.
Have you understood?
Yes, madam.
Okay. Roll number 62, Sanket.
Yes, ma'am.
Okay, you have understood
Yes.
which algorithm we have studied right now? Yes, roll number 62, Sanket. Tell me which algorithm we have studied. काय कळलं ते सांगा तुम्ही, तुम्हाला काय कळलंय आता? 62. So shall I consider you were only present for attendance? Roll number 62. I won't reply. Roll number 62. Yes, tell me fast. Roll number 62. Just check whose mic is on. A division, roll number 68. Aditya.
Yes, ma'am.
Have you understood whatever is taught today?
Yes, ma'am.
Which algorithm we have studied today?
Warnock algorithm.
Okay, very good. Roll number 62. आता तरी सांगू शकाल. Okay, don't attend the lecture for the sake of attendance. If you are attending the lecture, that means you should know, you should gain some knowledge out of that. No, you should gain the things which are not known earlier to you. काहीतरी नवीन शिकण्यासाठी लेक्चर अटेंड करा. तुम्ही लेक्चर अटेंडन्स साठी नाही अटेंड केलं तरी चालेल. मला पर्सनलला व्हॉट्सअप करा की मला लेक्चर अटेंड नाही करायचं, फक्त अटेंडन्स लावा. आय विल पुट युअर अटेंडन्स. Okay, so we will stop for today.
Hello, ma'am.
Yes,
मॅम एरिया सब डिव्हिजन आणि वॉर्नोक अल्गोरिदम सेमच आहे का? त्याच्यात पण डिवाइडेड
yes, yes, the name is same. That is, म्हणजे तुम्ही वॉर्नॉक पण म्हणू शकाल त्याला किंवा एरिया सब डिव्हिजन पण म्हणू शकाल. ही मेथड जॉन वॉर्नॉक या सायंटिस्टनी किंवा या पर्सननी इन्व्हेंट केलेली आहे. अँड दॅट्स वाय द नेम इज गिवन ॲज वॉर्नॉक अल्गोरिदम. अँड द प्रिन्सिपल बिहाइंड इट इज एरिया सब डिव्हिजन, म्हणून त्याला एरिया सब डिव्हिजन पण म्हणतात किंवा वॉर्नॉक अल्गोरिदम पण म्हणतात. दोन्ही अल्गोरिदम एकच आहेत. हा, okay, so we will stop here for today. The Warnock algorithm is over now from this chapter. If you have not understood, then I will repeat the Warnock algorithm or some points which you have not understood. Otherwise, we will go to the anti-aliasing and half toning. which is the last bit of this chapter, anti-aliasing and half toning methods. So if you have any doubt, ask me. Otherwise, we will stop for today. Okay, is there any difficulty? Okay, so no question from your side. So we will stop for today. Thank you all.